Now let us solve few examples based on properties of determinants. Now here is the determinant that we have to evaluate. Now on its face it seems that it will be a very tedious calculation because the numbers are big involved here. But if you observe closely about the first two rows, we see that the numbers are very close to each other. They are somehow linked. So that is nothing but, suppose from second row, that is if we change the second row as second row minus 10 times first row. Therefore what we will get is, as per the property, the value of the determinant will not be changed because of this operation. Now the first row and the third row remain unchanged because we are not changing them. It's only the second row that we are changing. Now from 11, if we subtract the 10 times 1, that is nothing but 11 minus 10, we get the answer as 1 only. Similarly from 22, we subtract 10 times 2, that is 22 minus 20 is nothing but 2. And similarly 33 minus 3 times 10, which is 33 minus 30, gives us 3. So now as we can clearly see that R1 is exactly identical to R2, and therefore by the property that if any two rows or any two columns of a determinant are identical, then value of the determinant is straight away 0. So that is how we use these properties to evaluate a determinant. Now let's move ahead and see another type of question. Now here this is a prove that type of question, that is we have to show that the two determinants written here are equal without expanding either of the determinants. So that is the power of the properties. Now let us start off with the determinant on left hand side. Now if we compare the elements of both the determinants, we will see that the second column changes to a 1 1 1 and the first column changes to, the third column changes to A B C. So that means as if they are getting divided by the corresponding elements. So that gives us a clue, that is if we consider the first row and divide it by say A, that is R1 is changed to 1 by A into R1. Similarly, suppose we want to change the second row to 1 by B times R2, and the third row R3 is also changed to 1 by C R3. So whenever we are dividing a row by some number, basically we are taking that number common outside the determinant. So therefore the determinant on left hand side will become, since we are taking A common from first row, we will have A, then B from the second row and C from the third row. Now let's see what happens inside the determinant. In the first row, since we are taking A common, therefore what remains is 1 upon A, then A will get reduced to 1 and A square will get reduced to A. A square will get reduced to just A. Similarly in the second row we will have 1 upon B, 1 and B. And lastly in the third row we have 1 upon C, 1 and C. Now what happens is, now if we compare this particular determinant with the determinant on RHS, we will see that we have already got the second and third column as required on the determinant on right hand side. So that means we have to only now take care of the first column, and it is clear that if we take the product ABC inside the first row, the first column, then we will get the first column of the right hand side determinant. So therefore what do we do now is, we take the ABC inside the first column, that is we multiply each element of first column by ABC. So hence we will get the elements in the first column as BC then CA in the second row, and in the last row we will get AB, so which is the required column, and the other two columns are nothing but 1 1 1 and ABC, which is the required determinant. So in this way we have proved the required statement using the properties. Now let's move on to another question in which we have to show that this particular determinant is equal to the product of three factors shown on the right hand side. So this is slightly another different variety. Now to tackle this, let us observe that on the right hand side we have, say as an example, the subtraction A minus B. Now if we look back on left hand side, the A minus B will come from subtracting second column from the first column. Now we can anticipate that when we do that, 1 minus 1 will give us 0, and A square minus B square can be once again factorized as A plus B into A minus B. So that means from the first column we are definitely going to get A minus B as the factor. So let us do that and see how we can adjust it. So we have column 1 changed to column 1 minus column 2. So that gives us left hand side is equal to 1 minus 1 0. We have A minus B, and A square minus B square can be factorized as A plus B into A minus B. Now the other two columns remain unchanged, that is 1B B square and 1C C square. Now we can take A minus B common from the first column, so that we have A minus B. Now what remains in the first column is 0, 1 and A plus B. And we have the remaining columns as they are. Now looking at the pattern, what we did to get A minus B, same we can do on column 2 and column 3, from which we'll get the factor of B minus C as common. So therefore let us change column 2 to column 2 minus column 3. So therefore here we'll get LHS to be equal to, we have a factor of A minus B. Now we can move one step ahead and directly write that B minus C, which will have exactly same analogy as A minus B. So in the first column we have 0, 1, A plus B. In the second column we will have 0, 1, B plus C. And in the third column we have 1, C and C square. Alright. Now let us take additional step that now here we are free to evaluate the determinant so obtained, because now since we observe that we have two elements as 0 in the first row, so therefore if we expand the determinant along the first row, it is only one minor that we have to calculate. So therefore let us evaluate the determinant here. Now the question does not stop us from evaluating the determinant. It is just that we use the properties to simplify the determinant to maximum possible extent, and once it gets simplified to a very simple looking determinant, we can then take the decision to evaluate it directly. So now here we have, finally we have only one element in the first row, so therefore its corresponding cofactor is nothing but B plus C minus into bracket A plus B. So which comes from the fact that we have to multiply 1 into b plus c, and from that we have to subtract 1 into a plus b. So that further gives us the first factor is same, that is a minus b. The second factor is also same, which is b minus c. And in the last factor, if we simplify, we will get the desired expression, that is nothing but c minus a, because when we open the bracket we will have b term cancelled. Alright, so therefore finally we get in the last bracket as c minus a. So in this way we use once again properties to factorize the given determinant on the go rather than actually evaluating it to the final value.